All right, so today we're going to talk about percent yield. One of the things we're going to learn and talk about is when we do a chemical reaction, very few of them actually result in 100% of these molecules reacting. That's going to be a topic we save for second semester. But for now, for what we're talking about here, just know, like when I'm talking about this equation here, not all of the hydrogen in my reaction chamber will react with all of the atoms of the oxygen to produce water. We're going to be left with some hydrogen and oxygen here. So the questions that you'll be kind of presented with is if 18 grams of H2 reacts and produces 10 grams of H2O, what was the percent yield? Okay, essentially what our starting assumption is that not all of my H2 is becoming H2O. And that kind of makes sense. Like 18 grams of H2, if I'm thinking about molar masses here, H2 has a molar mass of 2 grams. So I know that I'm starting with way more than 1 mole of H2. But the molar mass of H2O is 18. So I'm ending up with less than 1 mole. So I already know I'm losing something here. So when I write a quiz, I typically write out the questions. Then I go back and I count the points to figure out, what should the total be. Essentially, we're going to have to do the same thing here. But in this case, we're going to do stoichiometry to figure out how much H2O I should have made. So the way that we're going to do that is we're going to start off with some stoichiometry. So we're starting off with 18 grams of H2. And, oh, there we go. And so my first conversion then is to take that times. Actually, if I know I'm doing stoichiometry, let's just kind of get these three set up here. All right, I know that I have my first one will be 1 mole of H2 over the molar mass, which we said already was 2 grams. The next one is the mole-to-mole conversion up here. Moles of H2 goes on the bottom, so 2 moles H2. 2 moles H2O goes on top. All right, now the last one's going to be 1 mole of H2O on the bottom, and then the molar mass of H2O up top, and that's 18 grams. So now I've got 18, times by numbers on top, divided by the bottom, ignoring 1. So 18 divided by 2, that's 9. These two cancel. So I've got 9 times 18. Let me get a calculator out. All right. Let's start at the beginning. 18 divided by 2 times 18. All right, 162 grams of H2O is what I should have made. All right, so now to find the percent yield, what I'm going to do is I'm going to take the mass actually created, and I'm going to divide that by the mass should have created. And I'm going to take that times 100. Essentially, my goal here is I need to get this into a percent because it's a percent yield. All right, so in this case, my percent yield just kind of following that, which this you should probably, if you don't want to memorize it, probably write this on your periodic table. Right on periodic table. All right, so what I'm going to have for this reaction here is the mass that we actually created is what's given to us in the problem, so that was 10 grams. We're going to divide that by the mass we should have created. That number comes from the stoichiometry. We found that to be 162 grams. Okay, so calculator back out. So I have 10 divided by 162. All right, so really, so I've got 0, oh, take that times 100. We end up with 6.2%. Let's actually go through, make sure we got this completely figured out. Times 100% equals 6.2%. All right, so that's the percent yield for this reaction. Um, Really, this could be due to a number of things. Maybe I didn't actually have 18 grams of H2. Maybe I put the H2 and the O2 in kind of a leaky container. Maybe I didn't give it enough heat energy to get the reaction started. Maybe I'm not collecting all of the water at the end. Water does tend to stick to the surfaces of containers, stuff like that. But yeah, so that's just percent yield. Essentially, you're doing stoichiometry, using the mass given, the mass of a reactant given to figure out how much you should have made. And then you're going to take how much the problem tells you you actually made of the product and divide that by how much you should have made. I know it's pretty basic, but percent yield is something that's done quite a bit to figure out if a certain chemical reaction is kind of cost effective to do, or if something needs to be tweaked, or maybe even if something's wrong with the equipment. So with that, good luck with the practice.